Hello, dear participants. Welcome to the fifth International Congress on Human-Computer Interaction Optimization and Robotic Applications. The symposium organized by Tokat Gazi Osman Paşa University from Turkey and National Technical University Kharkiv Polytechnic Institute from Ukraine. The symposium also is technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support symposium. Now let's start the symposium session. First paper belongs to dear Muhammad Rizvi. Dear Muhammad Rizvi, are you ready to present?
Yes, I am here. Can you hear me?
Okay, yes. If you are ready, you can start your presentation.
Okay, great. Thank you. Let me share my screen.
You have 10 minutes, please.
Okay. Thank you. Can you share my screen? Can you see my screen?
Yes,
Okay.
yes.
Okay, hello everyone. This is Muhammad Rizvi, and I'm here to present on the topic exploring the landscape of artificial intelligence in education, challenges and opportunities. Before I start, I just want to give a brief introduction about myself. Again, I'm Mohammed Rizvi. I have a strong background in computer science and engineering. I did my master's in computer science as well. I'm currently working as an analyst and also doing the research work related to AI. Let's proceed. So here is the agenda for today. I'll be discussing. I'll start with introduction. I will introduce what is AI and what are the challenges and opportunities of using AI in education field. Then I'll go deep into what exactly is artificial intelligence. It's robot or it's programs, what exactly how the things work in artificial intelligence. Next, we will go in challenges of implementing AI in education. What are the challenges? What issues the team is facing in implementing the AI solution in education domain? Then we'll discuss the opportunities for AI in education. There is plenty of opportunities for using AI in education. It can revolutionize the education completely. Then we go into the ethical consideration. Basically, there is a data privacy issue with sharing data to AI. So I will discuss that in a little bit. And then finally, I'll conclude my presentation. Introduction. So AI is rapidly growing in all the industries. It's exponentially growing everywhere. And it's basically, of course, it has challenges and opportunities. I would say it has the potential to revolutionize the way the people think. And not everything will be replaced by robots, but it will definitely change the whole environment. We will discuss how the AI will be used in classrooms, how it will be beneficial to teachers, of course, to students, and how they can perform one-on-one learning to both the teachers and the students. What is artificial intelligence? Artificial intelligence is basically a simulation of human intelligence in machines. Those are programmed to think like humans. So we programmed the machines to react in the same way as the humans will react. We provide them data and expect to give the best possible answer. So it has the ability to rationalize and take actions that have the best chance of achieving a specific goal. So whatever we are expecting, it will provide the best possible answer. In education, it can create a personalized learning experience for students. It can provide adaptive assessments and assess teachers in grading their assignments. So the teachers can focus on other stuff rather than doing the regular grading stuff or the admin task. It can also include intelligent tutoring system, chatbot, and virtual assistants. So if our students need help, it will be available 24/7, and it can provide answers to students as well as to teachers based on the area where they need help. For example, it can help teachers to build up their curriculum, their syllabus for the year or the next year, and compare it with what's going on in the other schools or the universities. Let's discuss about real data and synthetic data. So AI is all about data. So I've learned a phrase, it's called garbage in, garbage out in my engineering. So whatever we provide data to the system, it will give us the results according to the data we provided. If we provided good data, it will get a good results. If we provide non-realistic data, we'll get a non-realistic answer from the AI system. So what is real data? Real data is obtained from direct measurements, constraints by cost, logistics, and privacy concerns. So real data is hard to get. Whereas synthetic data is artificial data. It's generated data from simple rules, statistical modeling, simulation, and other techniques. By 2030, synthetic data will overshadow the real data. We'll have a huge amount of synthetic data, but not the real data. So let's talk about the AI statistics. Some numbers here. The global AI market is valued at over 136 billion currently, and it's growing every day. AI industry value is projected to increase by 13 times over the next 7 years. The AI market is forecasted to reach around 300 billion by 2026, and it expected to grow 120% year over year. So it just gives some numbers that how fast this technology is growing in the market, not just education, but everywhere around the world. And people are investing a huge amount of money to get their industry up to speed with AI. Now let's talk about the challenges of implementing AI. Of course, there is a cost associated. Some schools have that enough cost, but others don't. There is a privacy concerns because we need to provide data. Teachers training is also an issue. So teachers and students need to be trained to use those systems in an efficient way. and integrate into their teaching practices. I know each schools have their own requirements, so they have to adapt to the learning. Let's go one by one. So data privacy and ethics. As I mentioned earlier, we need to provide data to the system to get a good results. So there is a huge data privacy and ethics concern because it will be sharing personal data to the system, like feedbacks, grading, experiences. So there is a big privacy concern. Need for technical expertise. Both students and teachers need to have a technical expertise to use the system. They need to be trained, they need to adapt to the system, and they need to have a proper exposure to use the system. There is a potential for unequal access to technology. Some schools may have that technology, others don't. So there is unequal access. So there is a biased opinion possible there. Of course, the system, AI system will miss human interaction. It will be not exactly like human. It cannot replace human interaction for sure. And of course, it will have no emotion. It will be the emotionless. So it cannot handle the emotions. Now coming to opportunities, there are a long list of opportunities, but I'll be discussing the primary ones. Personalized learning experience can be created using AI algorithm. It can analyze students' data, and based on their weakness, it can provide answers. For suppose if a student is weak in math or a science, the system will provide him helpful and detailed solutions for those specific subject. Also, it can adjust based on the difficulty level of the student. So if the student is not performing well, it can bring up the questions which are not that difficult and probably give him something relatively easier to build up his understanding and concepts, also to improve the learning outcomes. Okay, so here is a picture which shows how AI can be used in education. So as you can see, it can be a time saving for teachers and professors. They can assess and perform grading using the system. It can tutor and assist students, provide 24/7 support whenever they need. It can give feedbacks to students and the professors as well. It can help teachers to become learning motivated. They can come up with the new ideas to educate and promote education. Also, it can enhance student health. It can talk about student health, discusses if student is going through any health condition, they can talk and discuss with the system. So going into one at a time, all the opportunities here, I would say the primary opportunities. As I discussed, it provides personalized learning. So depending upon the user, student or a professor, it can give a personalized learning experience to the users. If a user needs some detailed understanding in a concept in physics, chemistry, or computer science, it can provide only specific to that domain. It can automate the administrative task like doing the paperwork, grading, providing feedbacks. It can handle all that using the automated process. It can enhance students' engagement. So student can be more engaged. It can come up with the more innovative ways to work with and make student more confident in their concepts. Accessibility. The system will be available 24/7. It don't need like it has to be a specific time or date. It will be available 24/7 wherever student need, whether it's morning, night, whenever they need help, they can just use the system. Now coming to the ethical consideration, I think this is one of the big concerns for using AI in universities or the schools, because it requires real data to provide good results. And there is a big concerns for providing personal data to the system. So privacy concerns also arises from the collection of use of student data. So some people don't want to share their personal data, so get the results. However, these issues can be addressed easily because other industries are using this AI solutions heavily. For example, algorithms can be audited for bias, and data can be anomalized for protected student privacy. They can anomalize the data, so not the student name or specific data is available in the system. In conclusion, I just want to say that AI has the potential to revolutionize education by creating personalized learning experience, providing adaptive assessments, and assisting teachers in grading their assignments. However, there is some challenges to privacy, cost, and teachers training, but those can be handled easily. And of course, there can be algorithms to analyze the data, so privacy concern can be easily handled. Of course, AI can bring significant benefits to students and teachers alike. AI is not here to replace teachers, but it's here to help the teacher and students grow in collaboration and improve their learning experience and make a better future for students. And that's conclude my presentation. Thank you.
Thanks for your presentation. Dear participants, do you have any questions about the study? Okay, no questions. Thank you again. I wish you success in your career, dear Muhammed Rizvi.
Thank you.
Okay. Dear Ruhi Sille. Are you ready to present your study? Dear Ruhi Sille. Can you hear me? Dear Ruhi Sille.
Okay.
Okay. Are you ready to present?
Yeah, I am sharing the presentation, sir.
Okay. We are waiting your sharing. You have 10 minutes, please.
Am I audible to all?
Okay. You can start your presentation.
All right. So I'm just trying the slide mode. Okay. Good evening, everyone. My name is Ruhi Sile. I am going to present this paper entitled Metaverse and Healthcare, which is an empirical investigation. Paper ID is 96. So let's proceed with the outline first. So in our outline, I'm going to first elaborate something about the metaverse, proceeding towards the healthcare industry, and also the abstract of why the study was planned to come out and what was the idea behind it. Moving further with a certain set of use cases of metaverse in healthcare. Then further with the literature review, although much research is not being yet done with the integration of metaverse in healthcare, but yes, the some of the papers have been introduced in this. Next is the example or a flow chart in which you can identify how the virtual clinic can be planned out in case of metaverse. Proceeding further with the drawbacks, conclusion, and the references. So let's begin with the introduction. So while we are starting with the metaverse, so it is a virtual setting which provides experience in the real-time scenario. For example, if the patient is very ill, could not enter into the hospital, could not reach up to the hospital, can be totally benefited from this kind of environment in which the doctor can actually examine the patient along with all its the complete diagnosis and the prognosis. So in this major categories of the use cases which found in line which was found linked with the healthcare are augmented reality, virtual reality, and the extended reality, including the metaverse world. For some of the security point of view, we have also added this, not we, but the research is going on in which blockchain is added to provide the security in the metaverse environments. Since we all know our patient's health, any human being's health is the most important thing. To maintain that particular part, we really need to have accurate and precise the diagnostics as well as the imaging technology we need to have inside the metaverse environment to give a real time feeling within that particular environment. So this paper discusses the clinical and diagnostic advancements which are achieved through the integration of metaverse and the healthcare. Moving further with the abstract, so in this we have analyzed few research which is which tells us where actually in healthcare industry metaverse could play a major role. For example, it could either play a major role in just accepting the health records, the electronic health records of the patient, not only the present data but also the past data, so that the so that when metaverse is aligned with the artificial intelligence technique, it could result in some fruitful thing, that is maybe the prediction of the healthcare. So metaverse offers a collection of technologies which can be used for patients diagnosis, eliminating the need of doctors to be physically present. So for example, a patient is suffering from a very chronic disease can be analyzed in the metaverse healthcare industry without actually requiring the doctor to come into the geographical location. So there are so many cutting edge developments which are already happening in the metaverse healthcare industries. All those developments have been explored in this paper, so that we could provide an additional advantage by merging the metaverse with the healthcare. Now, by looking into the various literature survey papers, we have analyzed the various use cases of metaverse in the healthcare. So some of the use cases were basically divided into 3 categories. One is your augmented reality with the virtual reality. Under this, few techniques have been analyzed. For example, if only the behavioral or the mental health of the patient needs to be analyzed, that could be easily done in this particular use case of the metaverse. Although metaverse is a combination of the augmented reality, the blockchain, the extended reality, and in the augmented reality, we have this option to train the doctors all over the world without actually changing their geographical location. Second could be the pain management. For example, if the patient is not knowing but is suffering from some severe pain, could be analyzed in this particular environment, and so on. The elder care where the old age people cannot actually go, or maybe they are having some disability, cannot actually enter into the metaverse, is part of this AR VR combination of metaverse and the healthcare. Next comes the blockchain. So blockchain's main role was to analyze the data, whatever the data has been shared by the patient, and what amount of data has been passed from the patient to the doctors, in fact, and are there any MRI scans or CT scans or any radiologist data which needs to be confirmed? All these things, security is provided by the blockchain, and even the data has been managed by the blockchain. So next, in the main metaverse or the extended reality version could include the various robotic surgical procedures which could actually happen in the metaverse, and we have the hospitals named after the metaverse kind of hospital, so that the full diagnosis of the patient could be done, including the surgical processes can be performed in the metaverse environment. So this was the analysis of this study. Now moving further to the literature review. So four metaverse environment was designed. Some was designed, so for example, in this Meta AI, it was designed for the medical imaging, in which the scanning and digital comparison, that what was the previous scan, and now currently what is the present scan, and what is how much information has been enhanced, or any unpredictable disease has been analyzed. All this has been done in this Meta AI. Then Rehabware is a VR rehabilitation solution, mainly for the people which are suffering from the brain disorders, so that they can have the confidence to regain the lost motor functions. Next is your Augmetics, which is an augmented reality based spinal surgical assistance system, which is a good example that the vision enables the clinician to view the patient's spine structures which is totally rendered in the augmented reality and the surgical site. Moving further with the flow diagram of the virtual clinic, as you all can see in this, that whatever the device, maybe an this fit bands or kind of a thing the patient is wearing, and from that some of the sensors are detecting maybe the heart rate fluctuations, maybe the blood pressure fluctuations. All those general clinical things can be analyzed from the patient, and doctor is again entering into that environment, which is here called as 3D virtual clinic. The data is being received, and all the doctors from all over the world can give their guidance without actually going to that place, but in the same metaverse environment. Once the analysis from all the experts over the world is done, then there is a virtual nurse which can, offer for the diagnosis and treatment. So this is actually we are moving towards, the world is moving towards, and various research is being in the part that we have to enhance this, enhance along with provide a more accurate solution to the patients all over the world. So advancement in technology, metaverse technology is going on in these days. But although the technology is quite advanced, but it is linked to certain drawbacks also. For example, we need to have access to that kind of setup. We although we don't need much, but yes, we need a very good, stable environment in which, when we are entering that environment, the patient who is not knowing even the layman person can, access that particular environment. And there should not be a scenario in which the richer ones can, be a part of it, and they can conduct their lab checkups through this. But also the normal people, general people can also have access to this. But the technology is very advanced, in which it is very tough to say that it will be accessible. For now, I am saying it will be accessible to all. Next is technological reliability. Yes, in today's trend, we are more aligned and we are more reliable towards the this upcoming technology like augmented reality, virtual reality. People have already adapted to this. But healthcare and metaverse combination is a bit risky, in which the people are losing the trust. But once the technology has been advanced, the metaverse environment is advanced, the reliability issues can also be thrown away, and it could be more reliable for the patients. Moving further with the privacy and data security, since all the data has been going towards the in the online environment, in the virtual environment, so there are chances that security could be side kept or something like that. But if prevented with certain high security features, cyber security features, then maybe there is a possibility. So these are I would say that these are not the research, these are not the drawbacks actually, but this could be the future perspective of the research, that advancement could be done in these particular topics. Human connection and empathy. Although metaverse provides a in-person kind of a personal setup, but still there is a bit of a loss of actual human connection because of the reliability issues. Moving further with the conclusion of this study, although it has gained so much importance in scientific, educational, medical communities, and researchers are continuously deciding to improve health using these technologies, but still there are privacy and security concerns, which I've already mentioned in case of virtual clinics also, but in case of surgical procedures which we are planning to proceed further, it could be a matter of privacy concern. Next is your virtual consultations may not be suitable for all type of medical disorders. For example, a person only needs a counseling session, then it is a good opportunity for the for that particular kind of patient. But suppose the person doesn't even know what is going through in the body of his or maybe he's not properly diagnosed, then in this kind of a situation, the physical consultation is more important. For now, we can say that. So next, moving further with the efficacy of the medical education and training. Yes, the training could be conducted, but it is limited as simulations in the online environment are a bit risky, and it cannot be able to fully replicate the real world experiences. Moving further with the ethical questions, that patient treatment, is it possible, it is not possible, it is realistic or not, or are we talking totally in the metaverse environment? It's still a big question and could be a perspective for the future as well. So apart from those future perspectives, we have a few more future scope like telemedicine advancement, artificial intelligence integration, since we are already asking the patients about the diseases, also including with the with the history of the patient. So maybe we could provide the online medicine kind of an environment in the metaverse, and the patient can there's a possibility, I'm just saying there's a possibility which can lead to metaverse integration with the healthcare, and their data-driven healthcare decisions, which are very important these days, that runtime decisions related to the patient's health is required, mainly in case of chronic diseases. These are the references. Thank you.
Thanks for your presentation. Dear participant, do you have any question about the presentation? Okay, no questions. Thank you again, dear Ruhi Sille.
Thank you.
I wish you success in your career.
Okay, thank you.
Dear Muhammad El Omoush.
Yes, here.
Okay, are you ready to present?
Yeah. I will
You can
present.
start if you want, you can start your presentation.
Thank you.
You have 10 minutes, please.
Okay, excellent. Can you see my screen now?
Yes.
Thank you so much. So, first of all, hi everyone. My name is Muhammad El Omoush, and this paper has been done by me and my professor, Dr. Tracy Mehigan. We are both from DCU University, Dublin City University in Ireland, and we are part of DREAL, SFI Center for Research Training in Digitally Enhanced Reality. Our paper is talking about leveraging robotics to enhance accessibility and engagement in mathematics education for vision impaired students. So the concentration will be on the vision impaired students, starting from the low range of maybe vision till the severe impairments for students. So our concentration will be on vision. The agenda for today will be to discuss and explore the use of robotics in education in general and its impact on learning and inclusion. Then we will move to the importance of using robotics in details in education, discuss it in details. Then in STEM education, more specifically. And then we'll be talking about challenges and the future directions in the field. And then we will be having some time to discuss if you have any questions. For the introduction and background, as we all know that mathematics education is very important for all of our students, as it is enhancing their critical thinking, their problem-solving skills, and it's a very basic subject for all students in all levels, regardless of their sensory disabilities or learning disabilities. We all know that that some students, they may face some challenges, especially our students, the vision impaired students. And the challenges are mostly towards accessing the mathematical content, because most of the mathematics curriculum or curricula is not, let's say, personalized for all students or for our students, vision impaired students. We all know that there are barriers created by traditional teaching methods, as I mentioned just now, because they are relying on visual representations. There are implications of limited engagement and understanding for vision impaired students. So the problem is now almost clear that traditional ways to teach mathematics is still not very efficient, and it's not including all students, let's say, especially in mathematics. So the proposed solution is to personalize the presentation of mathematics using multimodal feedback that combines spatial audio or spatial sound, we can say haptics, all within robotics. So we can feel and we can say that robotics, it has multimodal feedback. So it can provide us with spatial sound, haptics, and some other also modalities. To continue with the introduction, as we know that students varying, like we have students with, as I mentioned, sensory disability, for example, hearing issues, vision issues. We have students with dyslexia, for example, which is, we can define it as a learning disability. And it's also related to the vision issues. So as we can see here, dyslexia is a language-based learning difficulty that may cause learning mathematics to become a difficult undertaking. So these difficulties make the student more upset and make the student more, let's say, isolated in the classroom. Blindness is a sensory disability, and it can disturb the learning ability of mathematics. That's why we are looking for specialized tools used by vision impaired students in mathematics education. We all know that there are some limitations and challenges for Braille mathematics notations because not all students are familiar with, and it needs training for both teachers and students. We know that there are some other issues, like, for example, the lack of knowledge among mathematics teachers in integrating assistive tools as robotics, for example. And we have to know that there is an importance of inclusive education in equal opportunities for visual impaired students to assure that we have an inclusive environment within our classrooms. Educational robotics and the relationship between both HRI, human-robot interaction, and the inclusive education. Firstly, inclusive education, as we all know, that it's that all students have equal access to education, regardless any disability. And how it's related to the educational robotics, this is also discussed in our paper. How the accessibility features of educational robotics for vision impaired students can be enhanced, and what are the challenges around it. How the robots can promote the collaboration and the teamwork through robotics, in the classroom. So how robotics can be promoting collaboration in the classroom. And here I just want to talk about the having multiple modalities in a user interface has the benefit of spreading the interaction across various instances, because whenever we have one of the modalities is missing, let's say, or we can't reach it, so the other one is covering that. Spatial sound, for example, or haptics through robots may be a potential approach for students who are blind or have vision impairments. since they have difficulties understanding the spatial representation. So the sound is, and the haptics and the robots can be maybe a great chance, a great approach to be discussed and to be explored. The idea is to move the students from being sad and upset and isolated to being engaged and motivated through using robotics. And as I mentioned earlier, universal learning, or as I mentioned here, the inclusive education is very important and crucial in this stage, because we want to include all students in one page and put them in all one setup or one setting. So mathematics becomes inclusive and exciting for everyone when approached from the core, and starting with the basics along with robotics will be a great approach to follow. Artificial intelligence tools within robots have been integrated and brought into action education, promoting advancement in several areas. Intelligent educational systems offer teachers and students timely, personalized guidance and feedback. So the idea is to create an accessible mathematics for all. Also, as I mentioned, and here also, robotics has been identified as a promising tool for promoting STEM education, science, technology, engineering, and mathematics subjects. Robotics also presents a universal platform because it has many, let's say, feedback tools that students can use, and teachers as well. Human-robot interaction and its relationship with the mobile solutions and sensor technologies, this is all related because we want to encourage students to interact with a multisensory robotic system, which of course enabling touch, speech, and communication with the robots to enhance the mathematics education. Also, robotics is playing a great role in empowering engagement and accessibility. We were looking at VR AR in our paper as well, and how it has also a potential to be included within robots, and how teachers might use it to control robots remotely. Here, I'll just mention some or few challenges that we might face while using robotics in STEM education for vision impaired students. These challenges are mostly concentrating on differentiating robot parts, teaching students how to assemble them, providing them with the instructions, and to make these instructions accessible and readable for vision impaired students. We can provide clear and concise written instructions in accessible formats such as braille or large print, or maybe use the spatial sound here, creating audio interaction, developing tactile models or 3D printed representations, utilizing assistive technology such as screen readers, which can help students to read the instructions, promoting peer support and student collaboration. Robots are somehow the educational ones are affordable, so we can look at Lego EV3, NXT, WeDo. We will move, for example, to the microcontrollers as Arduino. We can move to the advanced ones like, for example, the Raspberry Pi. These are all can be used to create, for example, a humanoid robot that can be used as an assistant teacher in the classroom. The main concentration for robotics to be used in mathematics education for vision impaired students is that these robots have multiple modalities. So this approach is ensuring that all students can access and interact with mathematical content effectively. Challenges are that sometimes there are limited access, the cost, the ethical issues as well. As a future direction, we can say that virtual reality can be integrated into this approach, and there should be more collaboration between academia, industry, and policymakers to enhance this approach. The conclusion here is that robotics in education enhances learning outcomes engagement and critical skills development. Teacher training is crucial for effective implementation. So many studies demonstrated that positive impact of robotics in education. The challenges are here, but we have to look more about how to solve them, how to overcome all of these challenges. And here is the references slide. And if you have any questions, you can reach me through these links, the email and LinkedIn. And if you have any questions, please let me know.
Thanks for your presentation. Dear
Thank you.
participants, do you have any question? Okay, no questions. Thank you again. I wish you success.
Thank you.
Dear Ahmed Raad Sabah El Rashid.
Yes, sir, I'm here.
Okay,
Let
if
me
you
share-
are ready, you can start.
Yes, let me share my screen, please.
You have 10 minutes at most.
Can you see it
No,
now?
yes, yes.
Hello, this is Ahmed Raad Sabah Al Rashid and my supervisor, Professor Timur Anand. My paper title is about age and gender detection by using phase segmentation and modified CNN algorithm. Abstract. The fundamental purpose of the field research known as biometric explore of development of reliable approach for identifying individual using their trace. Example of biometric identification include both physical and mental traits of individual as of a kind of physical identification, fingerprints and feature. Maybe compared and analyze human gait has been researched because it has potential to be used as a behavioral identifier in computer vision using convolutional neural network and a support vector machine. The capacity of estimate a person gender based on their stride was explored and investigated throughout our examination of CNN potential using for a gait-based gender identification. Will be strive for both high degree of accuracy and achieve computational cost. Now we talk about the proposed method, the architecture of the software developed to solve the problem of face detection, face tracking, and determination of age, gender, and emotional state of the face that present and describe for this. The software structure to be developed will be presented, detailing the blocks that compose it is an architecture. Finally, it will be described where and how the proposed architecture will be implemented. Now we have talked about software architecture. The input data of the system to be developed should be the image obtained through a visual spectrum camera. The input data should be the data of each face, age, gender, and emotional state. And the identifier ID for this process to happen. An architecture was designed for system. The figures show the schematic where it is possible to see the blocks need to transform the input data and thus obtain the output data. The blocks in the figure represent a part of the developed code that are responsible for performing the set of specific tasks. In the architecture, the figure, an image is captured and then detecting of the faces, and the must of be carried out the faces must be sent to each of these 3 blocks. And this will be carry out the necessary process and extract the necessary information from them. After that, these are associated of the data obtained from each block. And then we obtain the output data from the system. Now we have talked about face detection. In face detection block, all faces an image must be detected and located, and in each face. And this image must be cut out. The problem is very common image classification problem, and it's quite common in neural networks. The figures show an example of that, of what this block should be do. On the left, we have the input image, and on the right, we have the output image with the faces. This block is very important for this rest of the system, as the correct identification of the image will be lead to a good performance of remaining blocks. That block should be some Robinson and thus be able to identify face, even with some variation in humanity. Distance is also an important factor, and it should be able to identify faces and distance that can go up about 4 to 5 meters. Result: compared to the traditional CNN, the accuracy increase in our CNN can be attributed to the encryption of hair-like features, which is enhance the network's ability to capture local patterns and structures, resulting in improving face detection performance. The figure shows that comparison of execution time between the traditional CNN and the modified for a face detection task. In this comparison, our CNN consistently demonstrated lower execution time compared to the regular CNN. To reduce the execution time of our CNN can be attributed to the encryption of hair-like feature, which is lead to an optimized time performance. Here the conclusion. The study was carried out to identify the best work carried out without each of characteristics or to be determined which is type of a neural network. It was possible to verify that type of networks must be used networks where VGG networks or divergence network. The VGG network was transferable and virtual work and virtuality allowed with some changes of blocks and determine different characteristics. It was also possible to verify the network that had been studied to carry out the work of these articles were identical or similar to those designed in this article. It's then conclude that the architecture to be implemented should be similar to those referenced. The good performance that the neural network depends more on data and image used in the training. Thank you.
Thanks for your presentations. Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success. Dear Ahmet Rahit Sabah. Dear Ahmet Onur Kaplan.
Yes,
Okay.
I can start if you want.
If you are ready, you can start your presentation.
Thank you.
Okay, you can start.
Okay. Good afternoon, everyone. My name is, one second. I think I need to open my camera sometime. Okay, it's enough, I think. My name is Ahmet Onur Kaplan. I'm a unique hybrid designer at Aselsan Incorporated. Today, I'm going to present a paper named as wireless JTAG to USB emulator architecture, which supervised by Professor Dr. Fırat Harberaç and co-supervised Dr. Fatih Uysal. First of all, in order to better the course of the presentation, I will talk about which topics I will mention during the presentation in each order. We will examine the introduction section to understand the subject of the study. Afterwards, we will examine a very short summary of the literature researched within the scope of the study, and then the design of the architecture, the conclusions which we will obtain, and the future works respectively. The demand for reliable and self-aware equipment is increasing to the standards that must be complied in the aviation industry, getting more skilled day by day. As a result of that, manufacturers try to minimize the possibility of avionic equipment being subject again to some test parts of the relevant standards due to various reasons after delivery to aircraft, in order not to cause extra costs. Some of these tests performed depending on environmental conditions within the scope of NIR STD 810 and DO 160 can be given as an example. A unique equipment which has already been configured to tests to meet these standards while being delivered to the aircraft can be called back to the manufacturer from the active aircraft due to differences such as opening and closing of the avionic equipment, changing the components in the avionic equipment, or it can be malfunctioning of the avionic equipment. Due to the configuration updates of the programmable devices such as fine programmable gate arrays and complex programmable logic device or complex programmable logic device with JTAG interface in the avionic equipment, it is possible to the test applications from the relevant standards in case opening and closing of the avionic equipment. In order for this situation to occur, it is necessary to update the configuration of the related programmable device without physically opening avionic equipment. These configuration changes do not include updates to critical functions of the equipment or major changes in the function of the equipment. Also, the security of the wireless network must be ensured by the security protocols and features provided by the integrated circuit bridging the Wi-Fi network. In this paper, the emulator architecture design is realized, which converts the wireless JTAG interface to USB interface, so that avionic equipment that requires configuration changes are able to update the configuration without physically opening. In the related study, it is able to prevent equipment from being subjected to various environmental condition tests due to configuration changes, to carry out configuration changes to be made wirelessly and to protect the wireless network which is used for configuration changes against errors. And there will be a title of literature review, the differences between the existing studies in the literature and the wireless JTAG to USB and metal architecture study will be expressed. The difference of the related study from its counterparts in the literature is that the USB interface JTAG metal is supported by a wireless network. By supporting the related wireless architecture, problems such as the need for keying and limited accessibility brought by the USB interface are eliminated. In addition, since the related block is not used external part, it does not need it does not need does not need to be used and inserted of USB cable every time the differences is wanted to be accessed. Thus, it is provided great ease of use. In addition, the application of the design within the scope of the related study to a young equipment will bring perspective to literature. Thus, the limitation of the tests of the administrative standards that are presented to encourage these parameters. Finally, taking precautions against attacks with the study is important to enhance the dependability of the study compared to similar research. Now we can talk about architecture design. This architecture design employs an FPGA which has JTAG interface, FT2232D integrated circuit that transforms USB to JTAG interface, which is produced by FTDI chip manufacturer. And Wi-Fi module has a 60 system and module produced by wireless connectivity. Since this design expresses an architecture, the necessary architecture information to be given is realized without the passive components that will be needed, and assuming that the supply voltages needed by the integrated are provided to the necessary place. This is assumption of the program. General view of the wireless JTAG to USB and lateral architecture is shown in figure 1, as you can see. In the next sequential headings, the architecture in the figure 1 will example in the table left section to right section, part to part. First, JTAG interface design between FPGA and FT2232D integrated circuits. Voltage level converter is added to act as a buffer between the FPGA and the integrated circuit for the JTAG interface design. In case of different voltage level or excessive current in any of the tech signals, the corresponding buffer circuit is added between two integrated circuits. At this point, TXB0104, which is produced by Texas Instruments, bidirectional voltage converter circuit is used since the direction of the pins of the voltage converter integrated circuit, which also undertake the voltage conversion function, can be adjusted direction external. In figure 2, you can see the schematic connection of the FPGA and FT2232D with the voltage converter is shown. The other part of architecture is about a couple. But firstly, we talk about a little bit of FT2232D integrated circuits. This integrated circuit is able to work in full compliance with the USB 2.0 standard. FT2232B undertakes the task of converting the integrated circuit from USB to JTAG interface. The related conversion process is performed by arranging the data formatting and clock synchronization configurations of the multi-protocol synchronous serial engine. The other name is MPSSE controller provided by the FT2232D integrated circuit in accordance with the JTAG interface. Also, this integrated circuit has two channels, so A and B. It only has an MPSS controller and channel L. The FT2232D needs external non-volatile memory to edit this configuration memory map. Due to two restrictions imposed by the FT2232D integrated circuit, the external non-volatile memory to be selected must have a 16-bit valve configuration. This is kept from FT2232D datasheet informations. For this reason, the 93RC56 EcoProm integrated circuit with work with SPI interface, which is from the 93RC EcoProm family produced by Microchip, is used as the EcoProm related architecture. The schematic connection of the FT2232D and 93RC56 is shown in figure 3. The other part of JTAG interface design between FT2232D is signal presenter design. There are two signal pins, as you can see, XT input and XT output for the reference synchronous clock that feeds the FT2232D integrated circuit. XT input and XT output signals pins are used by connected to the input and output pins of the integrated circuit that provide the reference synchronous clock respectively. The 6 MHz 7 resonator, which is CSTIS6M00G53 produced by the Murata recommended in the datasheet of the FT2232D integrated circuit is used. Again, the schematic connection of the FT2232D and CSTM-S6M00G53 is shown in figure 4. The other part of this architecture is USB interface design between FT2232D and 60 system module. I can see 60 system module. I want to show that module ease of use because of ease of use. 60 system module. Right module, wireless bridge module acts as a bridge between the other components and the network in the existing Wi-Fi network. The Wi-Fi module is able to configure, monitor, and manage the wireless network via connecting interface through an available dedicated console port. It creates an operating system with the single ARM Cortex-A5 core. It supports its processor with 2 gigabit LPDDR2 RAM with volatile memory. Additionally, it has 4 gigabit and 8-bit NAND flash RAM volatile memory. These processors, ST-RAM and flash memory are due to the operating system usage. You need for this architecture this operating system. As you can see, USB connection schematic between Wi-Fi integrated circuit, Wi-Fi module and FT2232D. Yes. Secret of Wi-Fi network between Wi-Fi module and wireless network users. Last part of architecture. Wi-Fi module is able to offer a variety of security options to ensure the confidentiality, integrity, and availability of data transmitted over Wi-Fi networks. The Wi-Fi module is fully compatible with IEEE 802.11 AC standard wireless local area network interfaces. The Wi-Fi module provides full support for Wi-Fi protected access through authentication, data encryption, and BT protocol stacks. Also, Wi-Fi protected access through person is used as the access to the wireless network is limited within the scope of the relevant architecture. The firewall is set to restrict traffic based on IP addresses, port number, or other criteria. The Wi-Fi module has a secure boot option that prevents unauthorized software from running on the module. This ensures that the module provides trusted software. Now, we can talk about conclusion. Configuration upgrades of remote equipment with FPGA JTAG interface using the designed wireless JTAG to USB and metal architecture prevents repetition of environmental conditions such as vibration and temperature tests from STD 810 and 260 standards. The implementation of FPGA programming over the wireless network using the related architecture offers the extra labor, the expenditure made within the scope of the tests and the delays in executing the tests. In addition to this, wireless network attacks by spies during FPGA configuration updates were also foreseen and precautions were taken for wireless network security. For this reason, it will be more appropriate solution to apply the wireless JTAG to USB and metal architecture instead of choosing the legacy programming methods during the design phase of new generation avionic equipment. Additionally, for future works, it is possible to develop the design architecture with various additions in line with the prospective applications of the achievements obtained within the scope of the related design architecture studies. First, instead of connecting the JTAG interface connection in the existing architecture to a single programmable integrated circuit, the ability to configure multiple programmable integrated circuit with the help of multi-drop JTAG multiplexer integrated circuit can be added to the architecture. This makes it possible to configure programmable ICs in different scan chains. Secondly, instead of using the FT2232 integrated circuit as a JTAG to USB interface converter, it is possible to use FTDI manufacturer's chip, which is FT4232H integrated circuit, which includes a PSSE controlled inversions, not like FT2232 integrated circuit. In this way, it can ensure that the configuration of the MPSSE controlled in the other channel is different from the programmable integrated circuit using the first channel and is configured as a programmable integrated circuit with TRST signal, test reset signal. Thus, it will be possible to configure programmable integrated circuit in two different instructions. Before the end, I would like to thank my company, Aselsan Incorporated, for their valuable contributions. That's all I want to say about my study. Thank you for listening to my presentation.
Thanks for your presentation. Dear participants, do you have any question about the study? Okay, no questions. Thank you again. I wish you success.
Thank you.
Dear participants, thank you for your attending. I wish all participants continued success. The session of the symposium is over. I would like to end this session. Have a good day. Good luck.
I'll ask a question.
Okay.
These videos could be uploaded on YouTube or any.
Yes.
Okay,
Yes.
okay.
Uh,
Thank you.